Welcome to the DIY Honda Garage channel. This presentation addresses the DTC P16BB, which refers to the alternator B terminal circuit low voltage detected in the Honda Accord 2023 and later models. This diagnostic trouble code indicates that the powertrain control module, PCM, has identified that the power supply voltage from the alternator is not meeting specified parameters. The PCM monitors various electrical components, including the amount of power generated by the alternator and the voltage supplied to the PCM. When there is a discrepancy, the PCM stores this code to alert the technician to supply voltage issues in the alternator circuit, underscoring the importance of the alternator in the overall vehicle electrical system. Understanding this DTC is crucial for accurate diagnostics and repairs to ensure reliable vehicle operation. The DTC P16BB indicates an issue with the alternator B terminal circuit's voltage supply. The PCM, or powertrain control module, is the brain of the vehicle's engine management system, responsible for monitoring various systems operations, including power generation from the alternator. The alternator is vital as it charges the battery while supplying power to electrical components. If the alternator fails to generate the correct voltage, the PCM recognizes this abnormality as insufficient input power, triggering the DTC. This specific fault may arise due to loose connections, faulty components, or other electrical issues that prevent the alternator from functioning correctly, thus affecting the entire vehicle's electrical system. Inspections relating to this DTC focus on checking both the external circuit connected to the alternator and the alternator itself for potential faults. Several factors can lead to the P16BB code being triggered. First and foremost is the possibility of a faulty alternator, which may not generate the required power output. A malfunction within the alternator, such as worn components or internal shorts, can lead to low voltage readings. Another potential cause is loose electrical connections, which can hinder proper power transmission from the alternator to the PCM. Bad fuses in the ACG_+B line are another frequent culprit, since a blown fuse can disrupt the power flow entirely. Lastly, wiring issues, including frayed or damaged wires, must be inspected, as they can cause intermittent connectivity and lead to erroneous voltage readings. When experiencing DTC P16BB, the vehicle may exhibit several distinct symptoms. Commonly, the dashboard will show warning lights, such as the check engine or battery light, indicating a problem with the power generation system. Drivers may notice battery drain issues, leading to difficulty starting the vehicle or the battery dying unexpectedly. Electrical components, such as headlights or the infotainment system, may malfunction or operate erratically due to insufficient voltage levels. Additionally, there might be poor engine performance, as the PCM relies on stable voltage for optimal engine management and efficiency. Recognizing these symptoms early can prevent further complications and lead to timely repairs. The first step in troubleshooting DTC P16BB involves starting the engine and checking for specific conditions. Once the engine is running, the technician should set the temperature control to maximum cool and operate the air conditioning to put additional load on the system. It's also critical to ensure that the blower fan is running at maximum speed. Headlights are on high beam, and the rear window defogger is activated. These steps create a controlled scenario to assess the alternator's performance under load. The technician must then hold the engine speed at 2,000 RPM without load, either in park or neutral, for 1 minute to observe the voltage output performance under these conditions. This process helps determine if the alternator is performing as expected and whether the cause of the low voltage can be identified. In the second step of troubleshooting DTC P16BB, you need to prepare by disconnecting the alternator B terminal from the system. It is crucial to ensure safety and prevent any short circuits during this process. Following the disconnection, you'll conduct a circuit inspection to check the ACG+B circuit against normal conditions. In this state, the vehicle should be in IG ignition mode, with the expectation that the battery voltage reads around 12 volts in a functioning system. If the measured voltage deviates from this, it indicates a problem exists related to power supply or component failure within the circuit. Establishing these baseline readings is essential for pinpointing the issue accurately. The third troubleshooting step for DTC P16BB requires a detailed inspection of connection conditions. Start by examining the connections at the alternator B terminal closely. Inspecting these connections will help identify any loose or corroded terminals that may impede electrical flow. Following this, expand the search to other related components, such as the alternator itself and the fuse holder A for the ACG_B line. Connections and terminals across these areas must be assessed for integrity and security. If any abnormalities are found during the inspection, these could be the root cause of the low voltage signal, resulting in the code being triggered, warranting further investigation or rectification. In the final troubleshooting step, if previous inspections yield normal conditions, the focus shifts to the alternator itself. In this case, if all other items tested are operational and no faults are found in the wiring or connections, the alternator could be determined as the cause of the issue. This step emphasizes confirming whether the alternator can produce adequate voltage. If it cannot, it leads to the conclusion that replacement or repair of the alternator is necessary. Establishing this final result is critical to resolving DTC P16BB and ensures that the vehicle's power generation capabilities return to optimal levels. Accurate diagnosis at this stage will help avoid unnecessary parts replacement. After repairs are completed for DTC P16BB, it's essential to verify the effectiveness of the repairs through thorough testing. Start by clearing any stored diagnostic trouble codes using a diagnostic scanner to reset the vehicle's systems. Follow this by taking the vehicle on a test drive to ensure that all electrical components are functioning as intended under various conditions. Pay particular attention to the battery status, alternator output, and the appearance of any warning lights, since they provide vital feedback about the system's health. Continuous monitoring of electrical systems will confirm that the issue has been properly addressed. This final verification is vital to ensure not only the absence of DTC, but also the reliability of the vehicle's overall electrical performance after the repair. Preventive maintenance plays a crucial role in averting issues relating to DTC P16BB and promoting overall vehicle reliability. Conducting regular inspections of the alternator at routine checkups can help identify wear and tear before it leads to failure. Ensuring electrical connections and terminals are clean, tight, and free from corrosion will help maintain optimal performance. Additionally, monitoring the battery health is essential, since an unhealthy battery can cause further strain on the alternator. Following these preventive steps can significantly prolong the life of the alternator and reduce the likelihood of future DTC occurrences. A proactive approach to maintenance is always more cost-effective than waiting for problems to arise. In summary, addressing the DTC P16BB requires a structured diagnostic approach. It is vital to follow the outlined troubleshooting steps judiciously to identify and resolve issues effectively. Particular attention should be paid to the connections and condition of key components such as the alternator, as they directly impact the vehicle's electrical performance. Regular maintenance is crucial for avoiding recurrence of such problems and preserving the integrity of the vehicle's electrical system. By understanding the root causes, symptoms, and solutions related to the P16BB code, technicians can ensure a smooth-running Honda Accord and improve overall customer satisfaction. Accurate diagnostics and timely repairs enhance the reliability and longevity of the vehicle. Please like and subscribe to the channel. See you next time.